One type of problem we have not yet covered and we need to is how to rationalize a denominator that has a binomial. It has two terms here. I can't combine them in any way. I want you to think about what we could maybe multiply this by. Because if it was just like 5 over root 3, we just multiply the bottom by root 3 and the top by root 3, and now we have root 9, and we're good to go. Because root 9 is 3, and I have a rational denominator. But what if I have a binomial down here? First of all, I can't just multiply by root 3, because that'd be great for this part, but we'd have to distribute it. Root 3 times root 3 is root 9, that's 3. But then I'd have 2 root 3 right here. So yes, I eliminated the problem here, but now this part's not rational, which is still no good. Lots of students tend to think about squaring this, multiplying it by itself. And if I FOIL here, notice I have 4. I get plus 2 root 3, and then plus 2 root 3, and then plus root 9. Root 9's okay. This is 3. But the problem is 2 root 3 plus 2 root 3 does not cancel out. So I want these two terms right here to cancel. How can I make those cancel? And we can do it by changing this to a minus sign. Instead of multiplying by 2 plus root 3, let's multiply by 2 minus root 3. So I've got 2 times 2, that's 4. 2 times negative root 3, that's going to change this sign right here to minus. Root 3 times 2. Positive root 3 times negative root 3. Well, now instead of being positive 3, it'll be minus 3. And notice now, not only did this part here become rational, but then these two middle terms are the same, one negative and one positive. Those cancel. So notice my denominator is now 1, a rational number. If we multiply the bottom by something, I need to multiply the top by the same thing. We distribute, and usually we wouldn't write divided by 1. We just write it as 10 minus 5 root 3. And our denominator is now rationalized. This, when you change the sign between the terms, this is called the conjugate. The conjugate of 2 root 3, I'm sorry, the conjugate of 2 plus root 3 is 2 minus root 3. You find the conjugate by changing the sign between terms. It is not the opposite. We're not changing both signs. We're just changing the one in between the two terms. To rationalize, if I have a binomial in the denominator, we will multiply by the conjugate. Let's try another one. Let's suppose we have 6 minus root 3 over 5 minus 2 root 3. 6 minus root 3 over 5 minus 2 root 3. There's nothing I can do here to simplify. I can't cancel these root 3's because I'm subtracting in here. We want to rationalize the denominator. We do that by multiplying by the conjugate of the denominator. So 5 minus root 3, the conjugate is going to be 5 minus 2 root 3, the conjugate is 5 plus 2 root 3. If I multiply it on the bottom, I have to do the same thing to the numerator. On the bottom, we are going to FOIL, and I would recommend starting with the bottom to make sure that you have a rational number. 5 times 5. These middle terms, if you did it right, should cancel out. 5 times 2 root 3. Negative 2 root 3 times 5. And they do cancel. And then I've got negative times positive, it's minus. 2 root 3 times 2 root 3. 2 times 2 is 4. Root 3 times root 3 is root 9. These two cancel. I get 25. 4 times 3 is 12. in the denominator, we get 13. That is a rational number. We get to FOIL in the numerator as well. 6 times 5, 6 times 2 root 3, negative root 3 times 5, negative 2 root 9. So I've got 30. These are like terms and can be combined. 7 root 3. This is 2 times 3. 24 plus 7 root 3 over 13. 24, 7, 13 have no common factors other than 1, so there is nothing I can do to simplify there. That's our answer.